Hello, welcome to our talk on using WeBWorK as a homework system for immediate feedback in preparatory chemistry. My name is McPherson.
I'm Bryan.
And I'm Mackel, and we're from the chemistry department at Portland Community College in Portland, Oregon. Thanks for attending our talk. So preparatory chemistry at Portland Community College is a prerequisite for our major level chemistry classes. The class was designed for students who either did not have high school chemistry or for students who needed a review. It also has the highest enrollment of any chemistry class at PCC. So switching some of our sections to an OER homework software system would have the greatest possible impact on our students. Besides the benefit of an OER, we also recognized that many publisher-created homework software programs really did not do the job we wanted them to do for this level of student. And what I mean by that is we felt their questions did not emphasize significant figures enough. They didn't have enough questions on dimensional analysis. And these were skills our students really needed some practice with. Specifically, many publisher-created homework software problems do not check significant figures in the student's answers. Instead, they just check that the answer is within a certain tolerance of the correct answer. And after practicing with these publisher-created software systems, we found that students, when they face a problem on a test, can't actually get the sig figs right in the answer quite often. And currently, we believe that no publisher can check significant figures on a randomly generated problem. And we thought we could do better. So most homework software systems come bundled with a textbook. So that means if you switch to an OER homework software system, you also have to switch to an OER textbook. So we decided to go with LibreText for our PCC Chem 151 sections that we're implementing WeBWorK. If you're not familiar with LibreText, they have several textbooks already on their website. They also allow remixing of their materials so you can create a customized textbook for your school. And unlike Stephanie and Lee, I do not come from a coding background. And I will say that remixing their materials is relatively easy once you've attended one of their workshops. And you can actually go to the LibreText webpage and check out our 151 textbook.
So we used WeBWorK for our online homework system. So what is WeBWorK? It's an online homework system that's been around since 1996. It was started by the Mathematical Association of America. It comes with an open problem library. It already has about 35,000 homework problems. Unfortunately, mostly these are math. There aren't many chemistry problems in there currently. It's run by the WeBWorK Project, which is a nonprofit that was founded in 2018. This is an all-volunteer community. You'll find that there is a lot of information online about where you can learn how to code for WeBWorK, and you can get support coding for WeBWorK if you're really ambitious. All the licensing for WeBWorK is the new General Public License version 3. This means that anything that is posted on WeBWorK or WeBWorK itself can be changed. You can alter anything, you can reuse it, but it has to be made publicly available. You can read more about this licensing if you look this up online. So, what does a student or an instructor see when they open up WeBWorK? It looks like a pretty standard homework program. It doesn't have any major bells and whistles. The students see their course name at the top, then they see a list of homework assignments. This course has 2 homework assignments. You can link WeBWorK to your LMS pretty easily. Once they click on one of the homework assignments, they'll see a list of problems. So we'll go to that next. Here's a list of problems from a problem set. You can see, now they can see how many attempts they have remaining. They can see what each problem is worth. They can see what the status of their grade is, all the standard things that you can see in a homework program. Then once you click on the problem, you can see what each problem looks like. Okay, so here are two example problems from the problem sets that we have programmed into WeBWorK. One of these is the way that, if you look on the left, the measuring with a graduated cylinder, that is a screenshot from a mobile device. That is what WeBWorK looks like on a phone. It works on all mobile devices, works on iPads. On the right, that's what WeBWorK will look like on a computer screen, most standard computer screens. So it's pretty versatile. There is also an option for students to be able to download a PDF, so they can get a hard copy of their homework as well. So it's very accessible option. It is screen reader friendly. So we really like it in that respect. If you notice, there is also on the right, on the writing formulas with polyatomic ions, you can see that the cursor is in the box with the blue. When you put the cursor on the answer that you are going to answer, a little helper box pops up. If you see that long, skinny rectangle on the right, that little box helps students input their answer. So that's like, it helps them put in exponents, it helps them put in fractions. They can also use some key words, like they can use underscore to put in subscripts, but they still show up as subscripts for chemical formulas. So it's really nice that the students can actually see the formulas as chemical formulas when they're inputting them. It really helps the chemistry students see everything and see where they might be going wrong. It also, if you notice, when they put in a parenthesis, it helps indicate that they're going to need to close their parenthesis. So little things like that are good for input as an input device. They also get, the standard check answers. So it shows them if their answer is correct, gives them a little feedback. There is a show me another problem. So if the answer can be randomized, it will randomly generate another problem. For the sake of their homework, they have to answer the first one, but it will randomly generate them another problem that they can use for practice.
So WeBWorK was developed for math classes, and thus it's missing features that a chemistry class would need. So we had to develop code, what we call the macros in WeBWorK, that will do things like recognize significant figures, extend all of the units that are necessary to do chemistry problems, and to even recognize chemical species as units, and a few other things. So we're going to be showing you a series of problems that use this new code that will help with writing chemistry problems.
Here is one problem that shows one of the more basic features of the macros written for chemistry. This one shows off significant figures. These numbers listed in the left column are all random numbers that have been generated by the system. The answers are also generated, so you do not have to pre-program in any answers. You just say, I need 2 sig figs, and the system will know that this answer should be 1200, and that should be 1230. Of course, you're not limited to just listing significant figures. The system knows how to use the significant figures in calculations as well. So what you're seeing on the screen are a series of randomly generated values that have significant figures. So the very first problem, 0.135, which is 3 sig figs, 0.23 with 2. In a calculator, of course, the students will see that it outputs as 0.03105. If you were to plug that in as is, the system would reject it. It is not correct. It knows that it should have 2 significant figures. So if I shave off those extra digits and adjust There you go. It's got the right significant figures, and it knows it's correct. Now that WeBWorK understands significant figures, we started to write problems that a chemistry student would see. That includes unit conversions. So here's an example of a unit conversion. Our professors like to have students show all their work at every step. And so we set up dimensional analysis problems like this. And so in this case, we would need to put the density inverted. We would write 1 milliliter in the numerator, 13.6 grams in the denominator, and the answer is going to be 0.044. And since this has 3 significant figures according to the values inputted, we should add a 0, and we can't forget the units. The units are all part of the answer. So you can see that everything is correct. If I were to replace the milliliter abbreviation with writing out milliliters, it should still work. And there you go, it works. And it's true for every part of this problem. So if a student didn't put a space in between the unit and the value, or they wrote out the unit, it all is correct. So the system is designed to catch any little differences between students. This is one of the major frustrations with other platforms where you have to be very specific in how you input your answer. Here's an example of a slightly more complicated unit conversion problem. And this is not just simple units. These are moles with chemical species attached to them. And the system still understands how to recognize these 2 sets of units, moles with the chemical symbol after it. So I am required to put in here, since we're calculating aluminum iodide, 2 moles of aluminum iodide. And then we're going to put in 3 moles of iodine. And the value should be whatever it should be. So you can see I got the ratio correct. The answer is missing, so it's incorrect. WeBWorK is fairly versatile in how you write your problems as well. Instead of having just very simple quiz type questions, homework type questions, we can actually try to train students by scaffolding the problem, making them a step-by-step problem, forcing them to go through each step. Here's an example that we used. So here you need to first start with an equality statement between liters and milliliters, and whether you write 1 liter is 1,000 milliliters, or 1 liter is 10 to the minus, or 10 to the 3 milliliters, or go backwards. 1 milliliter is 10 to the minus 3 liters. All of that will work. So I can check my answers here, and it's correct. And then I go to the next step. What is the conversion factor you can write? So we'll just do this. And the system is smart enough. If you put these answers in the other blanks first, it still knows it's correct. So 1 liter, check those answers. And then finally, we'll finish the problem by doing the math. We've got 0.07130 liters. We need to do a conversion, so 1,000 milliliters on top, 1 liter in the denominator. This is going to end up being 71.30 milliliters. And everything is correct.
Once we had written these WeBWorK problems and the students were utilizing them, we really wanted to know how much the students were benefiting from this process. So we came up with a data collection process. We have students in 151 that are in a hybrid class. They watch videos at home, and then they come to campus for an in-person lecture and an in-person lab. We assessed these students using ungraded quizzes as the students worked through a model on unit conversion. So we were particularly focused on those unit conversion problems that Lee just went over. In fact, we were specifically focused on a learning outcome that focused on 1-step conversion factors and 2-step conversion factors. We focused on sig figs and the showing of canceling of units of those particular problems. And so we stopped at 2-step conversion factors in our process. They took quizzes at 3 specific times in the process. They took an initial quiz before they interacted with any content. This will show, what they knew going into the process. Then they took a quiz after watching an accessible interactive video with embedded WeBWorK problems. This shows that WeBWorK can be embedded into other content. So the students were watching a video and then having to interact with these WeBWorK problems. And then they took a 3rd quiz after working through a WeBWorK problem set on unit conversion problems. And this was more like a homework problem set, but they didn't have any instructor interaction during this time. So they were just getting that feedback from the WeBWorK problem set. So this data that we took was instructor independent. They did not have access to an instructor lecture during this process.
We looked at data for about 70 students, and there isn't time in this presentation to show you our full rubric, but our rubric looked at if they answered the conversion correctly, if their answer had the correct number of significant figures, if their answer had units, and that the conversion factors they used were correct. So all of that went into their score. So before they saw anything about unit conversions, we did an initial quiz just to test their base level knowledge. For 1-step conversions, the average score on the rubric was 41%, and for 2-step conversions, 26%. So a lot of students could answer those conversions correctly for 1-step because they would cross multiply and divide, but they wouldn't get points for showing conversion factors. They typically also wouldn't get the significant figures correct in the answers. So between the first quiz and the second quiz, they had to go home and watch interactive videos. When they came back to campus the next week after watching the videos, we tested them again. The score for 1-step conversions went up to 71%, and for 2-step conversions went up to 59%. In class that day, they then worked through a WeBWorK problem set. This was really on their own without teachers helping them. And after that time with the WeBWorK problems, their average score on 1-step conversion went up to 82%, and 2-step conversions went up to 74%. So we were convinced from this data that our work with WeBWorK was actually benefiting students.
So if after all this you want to get WeBWorK and try out these problems yourself, there's a variety of ways that range from low computer skills to high computer skills. We're going to take a look at, very briefly, the highest skill level and the lowest one. So you may be interested in getting your own server. Your math department may already have one, so you should check with them. That's how we started. But beyond that, if you have to create your own server, this slide will give you the step-by-step on how to add our macros and our chemistry problems to your existing WeBWorK server once you get it up. If you'd rather avoid the hassle, one option is to use remote servers, and Runestone is one option. You can contact Alex at Runestone Academy for a course. The details are here. You can look at the website. But all of our problems will work on Runestone as well. So what are we doing next? Well, we're still adding features to the chemistry macros. We're still adding problems. And we have a repository on GitHub for people to help contribute. You need to be a little bit of a programmer to do that, but you can also report bugs. So if there are any things that are not quite working quite right, there's an issue tracker on GitHub. So we're developing new problems, and here is an example of one of the problems we're working on at PCC.
So the options are fairly limitless. We are currently working on things like drawing actual Lewis structures into WeBWorK using JavaScript applets. So here's an example of selecting xenon. We need to add xenon in the middle. We're going to select fluorine. We are going to draw fluorine with some solid wedges first, and then we're going to add the dashed wedges next. And since these are Lewis structures, we need to show lone pairs, which is not normal for most chem drawing programs. So I'm going to add 2 pairs of lone pairs on these. I'm going to add 3 pairs on each of the fluorines. And then see if I get it right. And it's correct. If I remove just one of those lone pairs, just to show you how this system works with it, check answer. You can see that it knows that most of the structure is correct. One of the lone pairs is missing. You can adjust the grading however you like to subtract or subtract a penalty.
So we're also starting to get some student-generated content. The pros of this are that students can connect with the content by creating a creative product that shows their understanding. This can generate some content for our WeBWorK problems for future students that they can relate to a little bit more, that are more diverse in subject matter. Sometimes as instructors, we come up with some pretty dry problems. The cons of this are that the problems have to be coded in by an instructor. Takes a little bit of time. We haven't quite come up with a way to keep an organized bank of these questions. This process is still underway. So that will be determined. We would like to thank you for listening to our talk. Of course, we did not do this work by ourselves. This was a very big project. We would really like to thank Patty Masseuse, Daniela Vukic, Mark Lowry, and Ken Friedrich for contributing to the content of the problems, to Mark Lowry, Barbara Pasquale, Stacy Fiddler, and Ken Friedrich for helping with the data collection and analysis, to PCC and Open Oregon for funding the development work, and really to all of the PCC students who put in answers we never anticipated in the beginning and really helped us with those robust answer checkers that we have now. And we'd really like to thank OpenEd 23 for allowing us to give this talk.